Yes, I think we can start, yes.
Okay. Well, hello, webinar guest. Thank you for attending. I'm Tom Oots, Director of Wireline Products for Wire and Bytes. We're introducing the next generation of downhole data acquisition cables. Our trade name is SlickLight. SlickLight lines look like slick lines on the outside, but are actually tubes that contain fiber optics or copper or both on the inside. Today we will be highlighting the SlickLight-C copper version, copper only version. The areas where SlickLight is already in use includes the North Sea, Saudi Arabia, Qatar, and now in the U.S., where Through Tubing Solutions in Pennsylvania are running the first system. During the presentation, there's an option on your screen to submit questions. And directly following the presentation, we will answer those questions plus any others you may have. Giving the presentation for us is Peter Bosick, our VP of Technology. Peter has been active in the development of fiber optics for the last 25 years. Very experienced person. So Peter, please begin your presentation.
Thank you, Thomas. I'm Peter Basic. I'm VP Technology of the Wires and Bytes. And this presentation is about SlickLight-C, where C stands for copper. Basically, we actually designed and planned SlickLight family of products for just a few applications, and you see them here in the picture. So it's basically SlickLine. It's designed for the well logging with the telemetry features and also remote powering. It has options for the DFOS. DFOS stands for distributed fully distributed fiber optic sensing. And there is another version already in use and in the deployment, which is also coil tubing application. So with these SlickLight-C products, you can address powering the tractor while logging and coil tubing. What are the expectations of the customer from the slick lines? Actually, it needs to be a very good trade-off between mechanical and electrical features. In other words, it must be strong, it must be small size of the slick line, but still it must have very good electrical features. And therefore, it is must be a good trade-off between these properties. Of course, there is a DFOS type which has even more features to be provided in the cable, and that is optical performance. And with the DFOS, with the combination with the DFOS, we have optical, mechanical, and electrical trade-off. And that's quite a challenge. SlickLight-C is electric slick line, and actually it's not a full profile wire. It's built different way. So it's based on the capillary tube. And from the outside and from the inside, we have, as you can see here in the design, on the right side, we have copper wire, insulation, and then strength members. All these is packed into 4 to 4.8 millimeters. It means up to 0.16 inches size. So it provides you, it gives you electrical features, it gives you strength, and still having everything packed in the small size. What benefits do they bring? So actually, there are two main benefits. First, you can organize communication with the downhole tools. And the second is you can power the tools. Of course, we have it's not a wireline. There is a limitation on the power, but still you can power some of the tools, including the tractors. The other benefit is you have actually functionalities of the electromechanical wirelines, but also the simplicity and efficiency of the slick lines. So actually, as many of you know, you have a simple pressure equipment on the top, which helps you keep operation efficient and small. It is, of course, low in size and weight. Still, it is strong. Like we already said, there are applications, and actually we are this today belongs to the niche called digital slick lines. With the copper, there is another possibilities even with the fiber optics. We'll come to that shortly. And also coiled tubing. Well, for the coiled tubing, these products are just a little bit different because technical requirements are different. And slick lights are injected into the coiled tubing. They don't carry too much weight, but they must survive actually high pressure, and they must be flexible. So therefore, the design is slightly different. So basically, all the slick lights are strong, flexible, and round. Sizes can go from 3.2 millimeters to 4.8 millimeters. Our objective was, or the goal was always to provide good bandwidth and stable electrical bandwidth in the operation. So meaning going many well runs up and down. Good on bending and good twisting properties. We are working very much to lower the resistance in order to provide more power to the tools in such a small size. Everything with the slick light, especially for the D-Force version, needs to be pressure proofed, so it must sustain 14,000 psi, for example, or even 15,000 psi. So it must be hermetically closed, corrosion resistive, build of corrosion resistive materials. Easy on sealing because you will be mounting the tools and sealing the cables and prevent liquids and gases to penetrate the tools and the cable. And of course, customers already, a few customers are asking combinations with the D-Force because they involve from the copper slick lights to D-Force versions. This is again capillary tube-based slick lines, and we go actually in two directions with our designs. One is actually on the left side. It's just a basic version in which we have copper conductor in the center, insulation, and the out encapsulation. So the electrical circuit is provided with a copper, central copper, and outer encapsulation. So that's just the basic version. It's not the strongest, of course. The more advanced version is on the right side, but we can go very small diameter with this one. It's for us. It's simple to produce. Everything sealing is easy, especially now when we are coming with a thick wall tubing using the TIG welding process and not only laser welding, for example. But then if you want to go deeper welds and use advanced features like the strength and very soon also advanced electrical properties of the encapsulation, you will go advanced version providing more strength. We can do thin layers or multi-layer or thick layer encapsulation. All of these are possible, and good performance on bending and advanced electrical path as well. We also called the advanced version SlickLight-C HD. HD stands for the heavy duty. And I'll be giving you just some results from the lab on this design. Exactly this design, which is now on your screen. So we have, again, the center copper conductor, insulation, the strength members or standing wires, and final encapsulation. And we provide the details, the cable characteristics always they are always specified in details in the data sheets which are available. And as you can see, for this design, very important parameter is of course rated tensile strength, and it goes 15.6 kilonewton, whereas we specify 60% of it as a maximum operating tension, and this is really also a kind of conservative parameter, 9.3 kilonewton. Our estimation, based on calculation, is that the collapse pressure would be 780 bar, but this is only calculation. Actually, it depends on the circularity of the design, and we believe we can go much beyond 1,500 bars in the real experiment, which we didn't done yet. And of course, all the electrical parameters you can see here, and this we are working very much on these to provide even better electrical performance for the future productions. The size of this one, which was tested, was 4.6 millimeter with a wall thickness 0.5. We can soon, very soon, add with the new machine line, add even bigger walls, encapsulation wall. Single layer will go 0.8 actually with the new production line. So a little bit of the lab measurements and actually lab activities on our side. So we do have mechanical, electrical, and optical equipment in our lab to do all kind of tests required for the SlickLight. Some of these equipment we developed by ourselves, and there is no other, to our knowledge, there is no other or no second equipment of that kind in the world. So in our test facility, we have, of course, temperature chambers and strain test benches. So we can even go to cryo temperatures minus 200 degrees all the way up to 300 degrees temperature for in our tests on the cables. On the strain bench, we can go 50 kilonewtons, and we do the strain evaluation not only with the classical strain gauges, but also with fiber optic using very advanced equipment. So we know exactly what is happening with the cables, and also even with the fibers inside the cables. So we can characterize all our products in tiny details. Of course, we do much of the customized testing. People ask us to do this, and we provide also the test the documentation for such tests. But that's all on the requirement, of course. And there is this line which was designed actually from scratch. Actually, this is a repeatable bending test machine, especially for the slip lines. It's just a machine which on one cable on which the actually slick line is mounted and fixed on one end, and then it runs through the pair of sheaves. Or reels, and ends up on the other end, but of course with a tension. It's an automated machine, and then these shafts with the sheaves, it walks left and right, doing constant bending plus minus 180 degrees. And we use and until cable starts to fail, actually. So the cable will not fail immediately, but you will notice the moment when the jacket is being already damaged, and this is what we register: how many bending cycles cable can go with these machines. We use different kind of sheaves. And then we do the statistics to learn the performance of each design. Yes, so we can exceed the load even beyond 500 kilos. We did already with 600 kilos, and sheaves, the OD of sheaves can be anything between 300 and actually 1 meter, 300 millimeter and 1 meter. And with this machine, we actually exceed the known standards like those from IC. And yes, so this gives us, actually, this is a simulation of a well run. And when you actually show the results, and this is what people ask us, look, your cable is fine, but look, we need to know how much well runs we can go with it in order to know our efficiency and costs. And after many measurements, and actually we made some statistics based on actually sheaves diameter as a parameter, and then rated tensile strength as another parameter, and then we counted. We run at least 300 cycles, which actually equals 150 well runs, because the cable needs to go one time down and one time up. So actually it's two bending cycles in our lab. And this is actually what we find out doing many of measurements using these different sheaves, based actually on the shape, and the sample was exactly that cable which was previously shown in the presentation. So we can advise people actually, which sheaves they should use in order to prolong the lifetime of the cable. And this is what they do actually. They order the sheaves based on this information. On the electrical side, well, the slick line is an electrical line, and electrical line has some serial resistance, inductance, and also the parallel resistance and parallel capacitance. So, well, what really matters is not, it's just the resistance and serial and parallel resistance and this capacitance, whereas this inductance plays the role only on very high frequencies. So it's dominated by resistance and capacitance, and this is our focus of our activities in providing you good parameters on the electrical side, so you can go higher bandwidth and you can deliver more power to the far end and the tools there. For this particular design which we are speaking, everything is already in the data sheet, so we provide these all this information even directly from our lab. We do it actually, we measure them before the bending and even after the bending, after 300 cycles to see the changes there. It's all available, and we have available in SI units and also in imperial units in the next slide, for example. So everybody can work with this data. Of course, you can see here, and we test everything even on the different temperature ranges. It makes sense to go 200 degrees. We haven't received requests for more than 200 degrees yet. Who knows for the future? But there's a lot of things can be done and measured in the lab. And now a little bit about the production facility. So there are two production facilities. We have one is in Perm, the main one, and the other is in US, in Arlington, Texas. SlickLights and are built in Perm, in Russian facility, which is a new facility. It's a little bit more than 10 years old. And the other, yes, now this is the Arlington manufacturing facility, focused on different application and different industry, power industry. And we are adding in our facility in Perm thick wall tubing mill. Already we have first productions, and now we are increasing the lengths, reducible lengths. So we'll be going up to, with the wall thicknesses, 1.24 millimeters, and with the OD down to 3.2 millimeters there. We'll be doing all kinds of steels, including super steel or super alloys there, to provide all kind of H2S resistant materials. This is actually, we have a good case study already in the US, but I will leave that one to Tom to to present you the through tubing solutions project in US. So Tom, please take the lead.
Thank you, Peter. Actually, for through tubing solutions, they chose to use the hybrid version. As you can see, the optic is still in the middle, but there is a copper layer around the film, the fiber in the metal tube. And they did this because of their particular needs. There's several large, fairly old oil producing fields that they are going to be targeting as their first area to service. And they need to still run some regular tools, currently memory tools, but they now will be able to run those tools continuously, as well as use the fiber elements to detect any issues in the wellbore itself. Next slide, please. So this is a few pictures. The cable was installed by an installation company, and Through Tubing is a company that has both SlickLine and E-line services. And at the moment, all of their SlickLine units were busy with jobs, and so they chose to put the SlickLight on a regular E-line truck. And that's no big deal, really, except it's a little bit harder to set it up, but once you get it set up, and I think the next slide will show that the bottom end that connects to the fiber optic package on the inside of the reel, there's not a lot of room to work there, but the engineers were able to sort that out, and it works just fine. And the installation went well. It was put on the narrow side of the split drum, and there were no issues whatsoever. It went on with a double brake. Spooled very nicely. The diameter was laser monitored, and it was 191 plus or minus 5/1000ths of an inch. So extremely good diameter. Next slide, please.
Yes. So to make a conclusion before we ask the question and answer session, SlickLight-C is actually a family of carefully designed products. It's all manufactured actually under one roof, and the purpose of these cables are, of course, well intervention, well logging, remote powering, and also injection into the coil tubing. We try to organize the best trade-off between the mechanical, electrical, and also optical features for the SlickLight family. But still, we will be providing our standard product, but still we can customize to meet special requirements in the application. And actually, the wires are exactly about that, providing good products and also best possible post-sale support, and even helping customer in definition and design and application of all those electrical and DFOS slicklines, and that's the purpose of for Wires and Bytes. And actually, thank you for listening to this presentation, and we can now have question and answer session. So I ask Olga to moderate this part of the presentation.
Yes, sure. So good afternoon, dear attendees. Thank you for sharing your time with us. If you want to ask any question, you can drop your questions to the chat folder, or you can request and I will turn on your microphones
So no one has any questions?
There is a raised hand.
Yeah, there's a raised hand. Do you see the question, Peter? It says, kindly elaborate more on available outer casing material grades for H2S resistance.
Oh, yes, very good. So, yes, so we can do, for example, right now, 316L, which is a common. People just ask 316L, but we do also probably the same amount of products with Inconel 825 and also Incolor 825 and Inconel 625. And then we'll be adding more, actually, especially with the new tubing mill. So this is all H2S resistant material and actually going even beyond that on the corrosion resistance side. So we have plenty of choice there. Did I answer your question?
Yeah, I think so. Incolor 825 is equivalent to Super 75. And you may be more familiar with S75, which is a common material in slick lines and E-lines.
There is a raised hand by guest Jess. Olga, can you unmute him or her? Sorry.
Good afternoon. Actually, good morning from your side. Good afternoon from here in Brunei. Actually, I'm typing a question if you also provide termination tools like rope sockets and collector rings for power and data, because this will be incorporated into the system. Actually, we're on SlickLine services.
Yes, we do provide actually. We have actually accessories in our portfolio, but of course you are free to choose accessories which fits you the best. We can actually suggest you from our portfolio, like rope sockets and termination boxes, the ring collectors. Yes, we can do that for you. It only we will communicate much on the technical level to to make it all suitable for your equipment and your application.
All right. Thank you for clarification.
There's another question, I think.
One more question with regards to the limitation of the sheaves diameter. You have mentioned that you have 300 mm diameter. That was very small for a normal slick line. But then your diameter is 4.5, which is about 0.2 inch. You mean that from 300 to a bigger size will be possible for these cables? Or do you have a standard like rule of thumb, like how many times diameter of your cables?
Tom, will you address this one or me?
Yeah, it depends on the diameter of the slick light, but we recommend pretty large sheave wheels actually, because this is a tube, and not only do we recommend a larger diameter for the 3.2 millimeter, which is a 125 inches, we recommend an 18-inch sheave, and for the larger sizes, a 20 or 24-inch sheave. As you get up to the 4.6 and 4.8 millimeters, we recommend a 24-inch diameter sheave. And the groove size is also very important, so that the full diameter of the tube is supported. And there's a company in the U.S., WTI, that makes a tube with a replaceable groove inserts. And you can either go to them direct, or we can provide that to you as part of our services. It's no problem. So if you need really specifics, my email address is on our website, tom.oots@wireandbites.com, and you can just send me what you're looking for, and then we can provide a very detailed quotation, including all of the parts, the cable head, the shears, all of the accessories you need. So don't feel free to ask for that, and we'll be happy to provide it.
All right. One more question. If this is available in the market for rental or for purchase?
We don't provide it for rental. It's just for purchase.
Okay. All right. I think that's all from my side. Thank you very much.
All right. Thank you.
So there's another question.
And we have, yes, 2 more questions in the chat. What special tools, if any, are needed for deployment of SlickLight-C?
Well, we try our best really to avoid inclusion of any special tools. We want people just to use standard everything. This is exactly our idea. So except for, I don't know, some D for slickline, we really don't have any special tools involved.
That's true. Well, we do ask you to pay special attention to the core size on your drums. Normally, you can use the same drum you use for your slickline, but we'd like the core size to be at least 15 or 18 inches. And sometimes on the older drums, the core size is smaller than that. And then the shear wheels, slightly larger than you might normally use, with the groove very tight to the diameter of the product you selected. That's the only two. Everything else, the equipment on your normal slickline unit, or even your E-line unit. I mean, through tubing used an E-line unit because that was what they had available. And other than putting the connection on the side of the drum, it works fine. So, and a SlickLight-C, you don't have to buy anything else. If you have E-line services, then you can use the same data collection equipment, the Warrior system, that you do. But if you don't, if you're just a slickline operator and you want to start using the copper version, then you'll have to buy a data collection system, and the most common one is Warrior. It's produced in the United States. And again, you can buy that direct, or we can include it as part of the quotation. And then that would include the collector rings, of course, and a cable head that accepts that added feature. So we can provide all those things for you, or you can do it yourself.
I think there are more questions there. Olga?
I'm sorry. We have another question about the capabilities related to conveying and shooting guns with the SlickLight-C, like safety aspects, maximum size of guns, maximum length, etc. You can read it on the chat.
Yes. There has been actually a request of this type. Actually, we don't have yet such a deployment to my knowledge, but for the using the slickline or slicklight for the perforation jobs or something, we have it now. There are some ideas on that. We are, to my knowledge, we are not there yet. Tom?
Yeah, I agree. The line was designed to replace the memory tools used on our regular slick lines, and so you no longer need to do that with this SlickLight-C. You can have, the communication power down and communication up simultaneously on the SlickLight-C. It's really not designed for perforations, although some of the heavy duty versions possibly could be, but it's really not the intent purpose for this product. And then the question right below that is jarring, and it is strongly recommended no jarring. The tube, well, we don't think will withstand that. And again, it's all designed to replace, the memory tools, and then for the fiber version to introduce a totally new data collection system with the fiber optics downhole, and you can profile the entire length of the well in like 2 hours. It's pretty fantastic. But that's a lot bigger investment, and we're happy to share that with you too. If you're interested in that, just email me, and we can give you an individual presentation or send you the video. You can watch it, and we're very flexible in how to help you understand the capabilities and limitations of these products.
Okay, one more question. It is common to test slick lines prior to jobs, for example, torsion tests, wrap tests, pull tests, etc. What field pre-job testing protocol do you recommend for your product?
The test that we are experimenting with in the lab, because it's a tube, you cannot do a wrap test like you do on a slick line. Wrap test is not applicable to tubes, but there is a bend test that we are experimenting with, where everybody has a vise on a unit, so you put the slick line in a clamp that's sized to the size of the slick line, and you bend it back and forth 45 degrees, and if it bends that once to the right and once to the left, it's deemed okay. But that is a testing procedure and process, and we'll update that as we get more lab results.
Still, some customers do actually much more tests, operators much more tests than we do, and they actually did this kind of tests because they are operators with their own lab possibilities. So, I mean, we need to ask, but maybe we can share some of these results also soon.
Well, that's true, but those are the tests that they've been doing in the yard. I'm pretty sure this question is related to tests on the job when you're reheading and that sort of thing. You want to make sure that the cable is good on that rehead area. So you have a very simple test. I think that's the question that they're asking. In the yard, in your lab back in the shop, and there are more tests that we can share with you on how to test the integrity of the line, mechanical and electrical. So just let us know and we can share. They're pretty extensive to go into, but those tests do exist. So if you just send us an email, we'll share those with you.
Yes.
Okay, no more questions on the chat. No more hands raised.
Very good. Then I want to thank you again for.
And I'm sorry, Tom. We have one more question.
Good.
Is the SlickLight-C recommended for deployment in pump down applications or deployment in frac wells while a frac is being pumped? Here I am thinking mainly of the fiber SlickLight for DTS, DAS monitoring. If yes, what are the maximum recommended pumping rates? Precious. It's on the chat.
Yes.
Well, honestly, that's a usage that we really haven't addressed yet. We believe that the heavy-duty version would withstand the pump down, but without actually having someone try it, we don't really know that would withstand that pretty tough application. So at the moment, we're not advertising or recommending that you would use that for a pump down until we get more research and more and development information. So at the moment, the answer is no.
These are actually, well, new products, so we will be having for sure such requests very soon, and some customer will be doing the trials on these applications, which we don't address just now. So I think in the very near future we'll have more and more information on all those niche applications.
For sure. So I'd like to thank everyone for attending. Our marketing group will be emailing everyone a follow-up form. So if you need to ask more questions, you'll be able to do that. You can rate the presentation and sign up for our newsletter. And I encourage you to contact myself or Peter. If you have any questions, you can contact us directly too by email. So again, appreciate your attendance and have a very nice, safe day.
Thank you, everybody.
Thank you.
Have a great day. Bye-bye.